All right, let's get started. People probably thought I already did it or whatever. That's fine. All right, unsaturated. So the different types of solutions, we have unsaturated. This would mean that this is less than the maximum dissolved solute. This is the maximum dissolved solute. And this is above the maximum dissolved solute when heated. Okay. So the three different types, unsaturated would be like if I just took salt, just a little, like a pinch or so, a little, and put it into water, okay? Where when we dissolve it, we can't see anything inside of it. So if we look at a glass of water and a glass of salt water, you can't tell the difference. They look identical, okay? Saturated would be where I continue to put salt into solution and it falls out. Another word for that would be just be collects at the bottom. All right. And then the last one is a supersaturated solution. And a supersaturated solution would be where we have the formation of a crystal using a seed crystal, which is basically just another form of the exact same thing. So the example here is an ice pack. Okay, not an ice pack you get out of your freezer, but an ice pack that you would get at the store. You snap the ice pack, and when you snap it, it actually causes it to turn into a solid. So it's a liquid originally, and then when you snap it in the middle, it actually causes it to turn into a solid. That's a supersaturated solution. If we were in class, we would actually do what's called a heat pack and ice pack lab. You can buy these at the store. They're really good for an emergency if you're out in the middle of nowhere and you need an ice pack. They don't go bad because all it is just chemicals sitting in there with usually a piece of zinc. And when that zinc snaps, it actually creates a boundary layer between the solution and the solid, and that solid actually gives the solution shape. And so when that happens, it actually forms a layer. Those are the three different types of solutions that we're talking about. So in this solution right here, where they're dropping, let's say this is just salt, okay? Because you guys know what sodium chloride is. So when they're dropping the salt into the liquid, they can continue to drop the salt into the liquid until you get to a saturated point where that salt actually starts to collect at the bottom. This would be like if you guys were making, like Kool-Aid at home, right? And you're like, oh, maybe a half a cup of sugar would be good, but a whole cup of sugar would be even better. And so when you're making your Kool-Aid and you continue to put sugar in the bottom, the sugar kind of starts to collect at the bottom, right? So that would be what we call a saturated solution, because we continue to put sugar into the solution and then it finally just starts to collect at the bottom regardless of how much we stir it, okay? Or we shake it or we heat it up. It doesn't matter, all right? So this would be unsaturated, where we can just continue to add and nothing collects at the bottom. It starts to collect at the bottom, and then eventually, once we get over here to a supersaturated solution, the only way to get to a supersaturated solution, the only way to go from here to here is to add heat, okay? So we'd have to take this solution and stick this on top of either a Bunsen burner or a hot plate or a oil bath or a water bath or whatever, and that would cause it to actually heat up, okay? All right, this is pretty cool. So that solution doesn't look like anything until the actual crystal forms. That is pretty awesome. And so what happens here is, because all of that solution is turning into a solid, all of that energy that was kept in the solid is now being released, and that thing gets hecka hot. Then we can actually form the crystals. If our solution is not pure, meaning there's imperfections in it or inconsistencies, then usually what happens is the crystal itself won't form, because crystals only form when there's very, very few imperfections. So when we get crystals in chemistry, we know that we've actually got a really pure substance, which is really nice, because that means that we did whatever it is we were trying to do correctly. Okay? So there are three things you need to know. There are three ways to increase the rate of dissolution, okay? And the word dissolution means to dissolve, okay? It's just a really fancy word for to dissolve, okay? So the three ways to increase the rate of dissolution. Number one, stirring, right? Kool-Aid cannot be made without stirring it. You could shake it, I guess. Okay, you could shake it, but shaking is technically still stirring. Okay. Number two would be breaking down into smaller pieces. Okay. Another word for that is crushing, right? Another word for that is crushing. Okay. More Trinity. I think that's Trinity. Has to be Trinity. And number three is the addition of heat. Right? Heat will dissolve just about anything. Okay. The reason why heat dissolves just about anything is because the amount of energy applied to a substance will increase the rate at which it dissolves, or the rate at which it forms from a solid to a liquid. Okay, morning. So those are the three ways to increase the rate of dissolution. If we have a quiz or a test, you will have to know those three. So these will be on there. And I can't draw a star this morning. All right, so you need to know these three things: stirring, breaking down to smaller pieces, or another word for that is crushing. And then an addition of heat would be the third one. All right. And guess what? In all forms of chemistry, these three things apply. So think about anything you do at your house when it comes to cooking, right? If you stir it, if you crush it, or if you add heat to it, usually things will happen, right? So when we talk about solubilities and we talk about things being able to dissolve in a solution, we're talking about stirring, crushing, and the addition of heat. Okay? All right, so we're going to talk about a couple definitions here. We're going to talk about solubility. We're going to talk about being soluble, and we're going to talk about being insoluble. Okay? Soluble and insoluble, all right? So soluble, I don't know why it's shaking so much. There we go. Soluble means that it can be dissolved. Can be dissolved. Okay? Insoluble means that it cannot be dissolved. So for example, right? Salt should be the solute, correct? The thing we're dissolving, right? The thing we're dissolving. And water. This is the solvent. Okay? This is doing the dissolving. Okay? So salts salt going into water, this would mean that salt itself is soluble. All right, it is soluble. Okay. Insoluble would be oil in water. Notice we didn't change the solvent, we just changed the solute. And we would say that it cannot be dissolved in water, right? Remember that oil and water, if you look at a beaker of oil and water, the water is on the bottom. This is the water. And the oil kind of floats on top, right? Okay. Whereas over here at the salt and the water, if you were to look at a glass of salt and water, you really couldn't tell. Okay. So those are our two definitions that we're going to be going with, which is soluble and insoluble. Okay. Heat plays a rather large role in these. Okay. So if I make things cold, think about trying to make spaghetti in cold water, right? Not going to happen. Rice in cold water, not going to happen. Okay, pretty much anything in cold water is not going to form, including Jell-O, right? Jell-O has to have heat in order to be able to form. If it doesn't have heat, then you can't actually get the gelatin to form and create those bonds between the Jell-O that need to form in order to have Jell-O. Okay, so when we talk about heat is a rather large constituent of this process. Okay, it's a rather large part of this process. All right, so there are some rules that go along with this, and I will post those rules online for you. But let's go ahead and take a look at those rules. All right, so we're gonna look at solubility rules. As a matter of fact, I think I printed this off. Pretty sure I did. I sure did. Yeah, these are the ones I want to use right here. Okay. All right. So these are solubility rules. And anytime that you have a quiz or a test, and not usually in college, but in high school definitely, even in AP, you'll be given a solubility list or solubility rules. Okay. So remember that soluble will usually have an S written next to it. Okay. Insoluble, we can just denote with an I. Okay. So capital S for soluble and a capital I for insoluble. You'll notice that some charts have partially soluble on them or partially insoluble. We're not going to be concerned about that. We're going to be concerned about the extents, okay? So it's either soluble, meaning it can either be dissolved or it cannot be dissolved, all right? So when we talk about being soluble, that means it can be dissolved, okay? Can be dissolved. And obviously the prefix in means cannot, right? Okay, so with that being understood, now we can look at these rules, all right? All sodium, potassium, and ammonium, okay? This is ammonium. Ammonium compounds or salts are soluble. So that means that if I had, let me move on to the next page over here so we can go ahead and look at some examples. So number one says all sodium, potassium, and ammonium are soluble. So examples of these would be like sodium chloride. Okay, that's soluble. Potassium, let's go with potassium phosphate. Okay, or potassium sulfate. Okay, that's soluble. All right, or ammonium hydroxide, which would be what you buy in the store that's called ammonia, right? Ammonia hydroxide. This is store-bought ammonia right here. Store-bought ammonia. But you probably didn't know that, did you? A lot of people just think that ammonia is NH3, which it is, but NH3 is a gas. And ammonia, if you were to actually take it out in gaseous form, it would actually kill you. Okay, if you breathe that in or you release it in the environment, in a closed environment, like in your house, you breathe it in, you can actually die from that. So that's not good. So this is actually store-bought ammonia. So what they do is they dissolve ammonia, NH3, into water to get ammonium hydroxide, which is pretty cool. All right, so those are some examples. These are all soluble, meaning that when we put them into a solution, they will dissolve in water. Okay. The next rule is all NO3 minus, which is nitrate, C2H3O2. This one is called acetate. ClO3 minus, which is chlorate. I'm off my chemistry game this morning. And ClO4 minus, which is called perchlorate. Those are actually really toxic for the environment. Super toxic. They also cause cancer. They're carcinogens. Salts are soluble. Okay, those guys are soluble. All right. So anytime that you see any of these ions in there, they're going to be soluble as well. All right. So examples of these be potassium nitrate. That's definitely soluble. We could go with acetic acid or vinegar, which would be HC2H3O2. This is vinegar. The proper term for that is acetic acid. We could do, let's do sodium chlorate. Okay. We could do potassium chlorate or perchlorate. Those would all be soluble. Do you guys get the point? You get the idea? Or do I need to go through all of them? Good morning. All of these rules that are on here, okay, meaning that if they say soluble next to them, okay, these guys right here are going to be soluble, which means they're going to be able to be dissolved. So you would write an S next to them. If you see these in there, then you would write an I next to them. I'm sorry, an S next to them. You see silver, lead, or mercury. Those are all insoluble. Chlorine, bromine, iodine are all soluble, okay? And then you have all of these are soluble except for the heavy metals, and the same thing applies down here as well. So anything that has the calcium, the strontium, barium, those are typically going to be insoluble, okay? So what is your homework going to look like? Your homework is going to look like this. We'll do that one next time. Okay, so here's what you're going to do. All right, this is what your homework is going to look like. So let me zoom in here. Okay, so what you would do is, it says, which of the following substances are likely to be soluble in water? Soluble means it can be dissolved, right? Write the reaction that happens when each soluble substance is dissolved in water, okay? So if something dissolves in water, I don't want you to worry about the second part. I don't want you to worry about writing the reaction right now. We'll do that next time, okay? All I want you to do for right now is I want you just to tell me, is it soluble or insoluble? That is your homework, okay? And this will be due on Sunday because today is Wednesday. I have trouble telling the days anymore. I hope you guys are probably in the same boat I am. It's hard to tell what day it is. All right, so let's look at a couple of these examples. I'll do 3 of these, and then we're going to call it a day on this one. Okay, so barium and nitrate. All right. So what you do is you basically just start with the top of the list. Okay. You start with the top of the list. All right. Let me zoom out a little bit so we can see that a little better. There we go. So if we start with the top of the list, number 1 says anything with sodium, potassium, or ammonium is soluble. Well, that's barium and that's nitrate. It's not sodium, potassium, or ammonium. So we would just go to the next step. All nitrates, acetates, chlorates, and perchlorates are soluble. Nitrate is right there. Okay? Now, the one exception, it says all nitrates. There are no exceptions to that rule, are there? So if there are no exceptions to that rule, we would write that barium nitrate, because it has a nitrate in it, is soluble. It's soluble. Okay? It's soluble because of rule 2. So in addition to this, what I would like for you to do is write, oops, I don't know, I was supposed to hit the camera. Write the rule number next to your answer. Okay, so what rule did we use to get this answer? We used rule number 2. So we would put comma, rule number 2. Okay, that way I know that you know what you're looking up. Because if you just say it's soluble or insoluble, you have a 50% chance of getting that right without ever understanding anything. But if you tell me that it's soluble because you use rule number 2, I will know that you understood what I'm talking about. Okay, let's look at zinc sulfide. All right, all sodium, potassium, and ammonium compounds are soluble. Nope, not part of that one. All nitrate, acetate, chlorate, and perchlorate are soluble. Nope. All silver, lead, and mercury are insoluble. No. All chlorine, bromine, iodine salts are soluble. No. All carbonate, oxides, sulfides, that is a sulfide, except calcium, strontium, barium, and barium hydroxide. Okay? So they're insoluble, which means that anything that has a sulfur in it, with the exception of calcium sulfide, strontium sulfide, and barium sulfide, are going to be insoluble. So we would put an I here because this is S mixed with zinc, which makes it insoluble. So we would say we put an I here, and we would say this is rule number 5. Okay. All right. We'll do this one more, and that'll be it. So ammonium and carbonate. Okay. So that is going to be rule number 1 right here, because it says all sodium, potassium, and ammonium compounds are soluble. So we would say that this is soluble, S, and we would say this is rule number 1. Okay? You guys are doing that whole worksheet. All right? So you're going to do letters A through U, and that will be due on Sunday. Y'all have a great day.